Here we have a particle moving in a straight line, so that at any instant acceleration is in magnitude half its velocity. Acceleration is equal to velocity divided by 2. Initial velocity is 3. Find, correct the 1 dp, distance in the 5th second. So that will be the distance travelled between the 4th and the 5th. So we need to maybe start this question with v. We have what do we know about acceleration is v dv ds, and dv dt is also equal to acceleration. So dealing with time here as well, we're going to need to start off with time here. So dv dt is equal to v over 2. So we're going to get dv over v is equal to dt over 2, or a half dt. And if we integrate these, we're given initial velocity is 3, so between 3 and then velocity, and the integral here between starting at 0 for time and up to time, we're going to get the natural log of v between v and 3 is equal to 1 over 2, and we're going to get t if we integrate backwards between t and 0, which will just give me a half t, but I'll put the t and 0 in. So we're going to get the natural log of v minus the natural log of 3 is equal to t over 2. Maybe just write it like this for now. So coming up here, the natural log of v over 3 is going to be equal to t over 2. So e to the power of the right hand side, t over 2, is equal to v over 3. So instead of writing the v over 3, we can put the 3 in front of the e. So now we have velocity in terms of time. So now let's look at the relationship between distance and time. S is equal to ut plus a half at squared. You know this anyway. The s dt is going to be equal to velocity. The s dt is equal to u plus at, twice a half, reduce the power. And we know that's equal to velocity. So now we have the s dt is equal to 3e to the power of t over 2. So if we cross multiply by dt, we can find distance travelled. ds is going to be equal to 3e to the power of t over 2 dt. If we integrate these, and that's the distance travelled between the 4th and the 5th second. The 4th and the 5th second. So put them in the correct place, 4th and the 5th second. Then we're going to get the distance travelled. So we're going to get s between s and 0 is going to be equal to 3e to the power of t over 2, and then we're going to have to divide by the differentiated, well, t over 2, 1 over 2, and then that's going to be 6e to the power of t over 2. That's going to be 6e to the power of t over 2, and that will be between the 5 and the 4. So we're going to get s minus 0, or just s, is equal to 6e to the power of 5 over 2 minus 6e to the power of 4 over 2, which is just 2. So s is equal to, I suppose we could just type this into our calculator. We could factor out 6e squared, and it's going to be 6e to the power of a half, or 6 by the square root of e, minus 1, or some version of this. Type this into your calculator to get the distance travelled to save me a bit of time.